This is Professor Pell, and we're doing confidence intervals for proportions first. So basic confidence interval is where you think the true answer is, because at the end of the day, you don't know what the true answer is. Um, you can guess within a range of where it is, which is called a confidence interval. So if you think you're going to get an exact answer in statistics, you don't understand anything about statistics. So first you need a point estimate. Okay, so that's basically some kind of sample set that it's going to give you a point of reference as to what the true population answer is, essentially. So at a local college, a random sample of 100 students is taken. The average age of the students of the sample mean is 22.3 years of age, right? So this is the point estimate. Because the sample says 22.3 years, okay? And the reality is, what are we trying to find? We're trying to find mu, the population mean. That's what we're trying to find, but we don't know that. We need a point of reference or a point estimate, which is our sample here. So the local college random sample of 100 students taken and found that 51.9% of the students are enrolled in liberal arts. All right, so that is our point estimate, 0.519. Does that mean that's actually the real answer? Who knows? So as to what the actual population proportion is, we don't know. Okay? So we're using the point of reference basically. So when they do samples of proportions in this book or many books, they either put a little hat on it, or they'll put a little quote, or they'll put something above it, to indicate that this is a sample and not the actual population. Okay, hence why in the stats one they put the little bar above the x. It's the mean basically, the sample mean, which is this is the population. Okay, so whatever estimator you're using, so these are both estimators, right? These are both estimators. Okay, they have to be unbiased, consistent, and relatively efficient, basically. Um, so when you make a confidence interval, it's at some kind of level, okay? And that confidence interval is basically using your estimate, which could be the sample mean, the sample proportion, any number of things, plus or minus whatever the margin of error is, which is the way you calculate that is different depending on what you're actually trying to figure out an interval for. So let's say, for example, we have a confidence interval that says 42.1% to 61.7%, and it's at a 95% confidence interval with a sample of 100 students in the summer liberal arts survey. So what does this actually mean? So we are 95% confident that the true population proportion is between 42.1% and 61.7%. Okay, so that means 5% of the time we're unsure. So there is a 5% chance the true population proportion is not in this interval. Okay, so you did 100 100 students in your sample basically, and you got some kind of point estimate. As to what that point estimate is, I don't know. I didn't put it here. It doesn't matter. And using that, you found a confidence interval at this level, basically. So the real answer is in here, or it's not. We're pretty sure it is, but the chances are wrong. So you're never 100% sure unless you have all of the samples. But if you had all the samples, you wouldn't be doing statistics, basically. Okay. All right. So This is the formula for the confidence interval for proportion, right? So basically, if you look at the parts of the confidence interval, you have your point estimate, which is the sample, right? You have what's called a critical value. It's a z-value, the same z you used in stats 1. And then you have the standard error, okay? And then both of these parts together make the margin of error, basically. So what you have, so you notice it's the same thing on this side, but with a plus, right? You have an estimator, plus or minus the margin of error. This is the whole thing is the margin of error, basically. Okay. So the difference between standard error and margin of error is when you add in the z, which is the critical value, just gives it a reference point on the x-axis, basically. That's what it really is. You need some kind of reference point. So what you'll see online is you'll either see a z with a star, or you'll see z with a alpha divided by 2. Alpha divided by 2, I think, is what's used in this book, and that's pretty confident. And these are some typical values, although these are wrong. I need to fix this, actually. You should be ... Well, we'll keep it that way, actually, because they're not exact, because I did put approximate. We're going to get the exact values. You're not going to use estimated values. You're just going to use the exact value. So before you can do a confidence interval, you need to figure out the z values, okay? So, excuse me, open up a spreadsheet here. So I'm just going to go to office.com and then open a spreadsheet. Okay, so I'm at office.com, I get a spreadsheet. Okay, so a little type in here. So I want z sub, do a little sideways slash if I can find that. Alpha divided by 2. Okay. Equals normal dot distribution is the, no, normal inverse, sorry. Because we're inverting the probability back to a z-score. So norm is the z-score, essentially, right? So this axis right here, if I get it to work, is the z-axis, right? From your normal or bell curve from stats 1. All right, so if I'm 95% confident in my interval, that means I'm 5% not confident. So that's how you get your alpha, okay? Because these have to add up to 100%. So if I divide the 5 divided by 2, I'm going to get 0.025, 2.5%. So 2.5% of the time, my answer is going to be wrong, right? Which means it's going to be more or less than what I think it is, essentially, as far as the point estimate goes, or where the actual population proportion falls, right? So we hope that our population falls within the interval that we think it is, but there's a 5% chance it won't. 2.5% above, 2.5% below, basically. Okay, so I need to figure out this z-value right here. So a lot of people who stats 1 made the mistake of just reading the problem and automatically putting in 95% into their calculator and or spreadsheet, whatever they were doing. It's not 95, because if I go from here to here, that's not 95. You have to add on the other 2.5% to get 97.5%. So 0.975, comma 0, comma 1, and that'll give us our approximate. Let's make this blue, format, color, blue. And let's move this out of the way a little bit. Layout, square. Okay, so I'm going to go to my spreadsheet now. Equals normal dot inverse. If you don't remember, it also pops up as you type 0.975, comma 0, comma 1. And again, remember 0 and 1 are the default values if you're not doing a specific problem, which is the mean and the standard deviation, essentially, for normal curve. Okay, so I got 1.959964, okay? 1.959964 dot 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 keeps going. Obviously you can make the box bigger if you care. You're never going to round it anyways. You're just going to use that exact value that's in the box later on. So if you scroll up, you notice it says 1.96 here. So clearly it's a rounded value. Okay. So pause the video, try one more for yourself. Okay, let's look at the next one. So if this is 90% confident, that means alpha is 10%, which means 10% of the time my actual answer is not going to fall within an interval. So if I divide that by 2, 5% of the time the answer is more than what we think, or the answer 5% of the time is less than what we think. So if I want to figure out this z value, I need to go from here to here, which would not be the 90. It would not be the 90, right? Because you have to add on the other 5, so you get 95, right? So what I'm going to do now is click this, paste this, change this to 95, right? And now you kind of understand why it's not z, it's a z alpha divided by 2, right? Because there's actually 2 values. Okay, so let's go to our spreadsheet. Equals normal dot inverse 0.95 comma 0 comma 1. Close that off. 1.64485 is good enough. 1.64485. It keeps going, but that's irrelevant. So 90% confidence, right? That was 1.65 according to the book. We got 1.64485, right? So you're not going to estimate the values. You're going to use the values out to 20 places, wherever it goes to, that the spreadsheet gives you when you do it. Okay. If you remember, there's 2 z values in this, right? There's the upper one, and then there's the lower one, right? Because you have z alpha divided by 2. There's 2 of them. Like, well, how do you get the other one? Well, we know this is 5%, correct? Okay, so from here to here is 5. So if I actually wanted to do that one, okay, whoops, where is it? Right here. I could copy this and change this to 5%, right? And I get the negative z value. Because if you remember the normal curve, right? This is obviously z equals 0, or z value of 0. These are the positive values on this side. These are the negative values on this side from stats 1, right? And if you remember the confidence interval, okay, there's 2 sides, right? There's a where did I put it? Oh, here it is. Plus or minus the margin of error, right? Because you can see that, plus or minus, because it's 2 ends basically. You could be wrong on one side or the other. That's why there's 2 versions. We only need the positive version though. Okay, so let's do a singular problem here. So I'm going to go up and I'm going to steal the formula right here. And put this down here. Okay, and we'll make it blue. Format, color, blue. Okay, and we'll scroll down. Okay, so a survey of college graduates of 1,404 former students. Of those surveyed, 323 said they paid for college with student loans. Determine the 92% confidence interval for the true proportion of students that paid for their college with student loans. Determine the meaning of the confidence interval by writing a sentence in context. Okay, so this p hat is going to be 323 out of 1404. I'm just going to copy the rest of this right here. Copy, paste. We'll come back to the z value after. So we already know this. I'm going to copy, paste. Ooh, I don't want that little hat though. And paste. So the q value, what I need to notice is sometimes they don't say q, they say 1 minus p. So I like the p and q. P for success and q for failure basically. Or is not, however you want to look at it. So essentially 1404 minus 323 gives me 1081. Okay, so 1081, and then we have 1404 there. Copy, paste, and we're going to copy this again and add a plus there. Okay, so this is my confidence interval for 92%, but I have to figure out the z-value to be able to get the final answer for both sides, essentially. Okay, so normal dot inverse. So we're inverting the probability back to a z-score, right, which is 92% here. But again, you don't put in 92, because if we're 92% confident, that means we're 8% not confident. Half of that's 4. 4 plus the 92 gives me 96, so 0.96, comma 0, comma 1 will give me some kind of value, which we'll come back to essentially, right? Okay, so we're going to pause there. We're going to go to our spreadsheet essentially and do the work in there. Okay, all right, so the things we want to put in here, let's just go to here and put P, Q, N, and Z, right? Notice I put a P with a little quote there because it's not the actual proportion of the population, it's the sample. So we need something to signify that it's the sample, essentially. Okay, so that was 1404. This was 323 divided by 1404. And this was, I already forgot, 1081. 1081 divided by 1404. Okay, notice those add up to 100%, P and Q, success and failure. Okay, so equals normal dot distribution. 0.96, right? Because it was 92% confidence interval, so 8% not confident, half that's 4, add it together, comma 0, comma 1. So there's my z alpha 2. Oh, what did I do wrong? Oh, it's normal inverse, sorry. Because we're inverting the probability of 96 back to a z. There we go. Okay, so these are the things that we need. What I believe you can do is I'm going to copy this. I'm going to go up and cheat real quick. I'm going to copy this formula to the spreadsheet. Just so you can see it as I work with it, basically. There we go. Okay. All right, so equals the point estimate, which is a proportion sample, minus the z-score times the square root of P times Q, success and failure sample, divided by the sample size. Enter. So I'm going to copy that now. Copy that. Notice how I went into it and did that and then changed this to a plus. Right? So the difference is that you get a minus here and a plus here, right? Notice I went into it and copied it this way. Copy. Okay. So those are the answers I get there, essentially, for the ends of my inequality. So I'm going to go to here and copy those down now. So I got, I'm going to scoot this down, 0.210393. Whoa, I didn't type there. 393 dot 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 is less than P is less than 0.249721 dot dot dot. Okay, that seems good. Okay, so our sample was 323 out of 1404, right? So if we looked at that in the spreadsheet, that says about 23% of them paid for college with actual student loans. Is that the true population proportion? We have no idea. It might be. It might be more, it might be less. So we think it's within this range here, basically, based on the confidence interval. So the true population proportion is within this range, basically. So in context, right, we believe we are, let's see, are 95% confident that the true population proportion of students that paid for college with loans is between 21.0393% and 24.9721%, right? This might not also be true because basically, oh, no, I'm sorry, not 95, 92%. I'm sorry, 92, right? So we're 92% confident, which means the true population proportion 8% of the time has an 8% chance of not being in the confidence interval, right? So this is our confidence interval right here. That's our confidence interval. Okay. All right. So the question is, well, how do you know what percentage to do? It's really based on the sample size and the margin of error, essentially. So in this formula, this whole piece is the margin of error. That's the standard error or standard deviation. Becomes margin of error when you add the critical value, which gives it a reference point on the x-axis, essentially. So you use this to establish sample size also. So I just told you 92% here, but as to what that percent should actually be is really dependent on sample size. And so essentially, again, that part of the confidence interval is called the margin of error, right? When you add the z-score and the standard error together. So if we solve this for n, right? So what I'm going to do here is I'm going to just change that to m instead of me. It's a little less confusing. I'm going to divide both sides by z. I'm going to get rid of the z alpha too, just keep it as z for now, just for make the algebra easy. So I'm going to divide both sides by z. So divide this side by z and divide this side by z. So as a result, I'm going to get this equals this. Okay. Then I'm going to square both sides. If I square both sides, square this side and square that side, that will get rid of the square root because square and square root cancel, right? So this will leave me with just this. Okay? But I really want to know the sample size, which is n. So I'm going to flip both of them, basically. So if I flip both of them, I'm going to take this, copy, paste. I'm going to put the z up here, and put the m down there. And then take these, put them on the bottom, and put the n on top. Okay? So the last step is to multiply by n on both sides. So I'm going to multiply by n on this side. No, I'm sorry, not by n. P and Q. P and Q times P and Q. So on this side, the P and Q's will go away, right? So you'll be left with n equals this, essentially. Okay? So that is essentially the formula, which the book doesn't necessarily give you. They just say calculate it from the margin of error, basically. The margin of error being, right, that part of the formula, right? Okay? Because this part is the standard error, which is standard deviation, and you add the z and it becomes the margin of error. So that part is used to figure out the sample size. Okay? All right, so I'm going to take this formula down here and do an example. Okay. So equals. All right. So the proportion of people who buy clothing online regularly. The previous study found that 66% of the people buy clothing online regularly for accurate 33% of the true proportion. What is the minimum sample size needed? All right. So we're not really sure which one's P, which one's Q. But let's assume that we do 0.66 for P. All right. Which would be 0.34 for Q. If I interchange these, would that make a difference? No. So it doesn't really matter which one's P, which one's Q. You could assume the other way because we don't know which one's a success, which one's a failure necessarily. But it really doesn't matter because it's interchangeable, right? So either way, they would be the same number of samples needed to prove buying clothes online or not buying clothes online. All right, so the margin of error here, we want to be within 3% accuracy with our answer. So we want our answer to be within 3% of the actual answer. Okay, so what we need is the z alpha 2, the z value, right? Copy, paste, equals, so normal dot inverse. Okay. So if we want to be 90% confident, right, 90% confident interval, that means 10% of the time we're going to be wrong, right, which means 5% too much, 5% too little. So if I add 5% to 95, for 90 I get 0.95, comma 0, comma 1, and we'll get some kind of answer here, right? Okay. So let's take that and put it into the spreadsheet here. So we'll go down to here and we'll do P hat, Q hat. We don't know yet. We need Z, right? Okay, so this was, I believe, 0.66, and this was 0.34, right? And the Z was normal dot inverse. I believe it was 90% confidence, so half that's 5, so add that to it, comma 0, comma 1. So there's the pieces that we need, right? And I can copy the formula here too if we want to look at it as we do it. Oh, yeah, I'm just going to copy this. Why not? Oh, I don't know why that went up there like that. That's interesting. All right, so we'll just put N here. Okay, so equals P times Q times parentheses the Z value divided by, I believe it was 3%, correct? Yep, 3%. And then we're going to square it. And there's some variations of this formula. Sometimes they score the top and the bottom separately. Same answer either way. So I'm going to get 674.5822. You can make that more if you want. It doesn't really matter. So we're going to go back to our sheet now. Oops, 674.58 if I can get. So 674.58. So that is the minimum number of samples. However, there's the problem. You can't have 0.58 samples or whatever it is. Let's put the decimals on there. Dot, 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 right? So if I had 674, that's not enough samples because it says I need this much. This is more than 674, so 674 is not enough. So the answer is, right, we're going to put greater than or equal to 675 samples. Right? That's how many samples you need essentially. Then we can say it is, let's tab it over. Style text. 675 samples or more. So if you want essentially to have a 90% confidence, you need that many samples and more. So if you had 676, you're not wrong. You have 677, you're not wrong. You can't really have a partial sample. And be careful how they ask the questions too, because sometimes they ask the number of samples needed or what's the minimum number of samples needed. So depending on how they ask the question, it might actually be 675 or more. So just be careful of that. All right, that's the end of this.